This Artificial Intelligence and Equality podcast is hosted by Carnegie Council Senior Fellow Anja Kaspersen. Together with Wendell Wallach and an international advisory board, they direct the Carnegie Artificial Intelligence and Equality Initiative, AIEI, which seeks to understand the innumerable ways in which AI impacts equality and international affairs. This episode features Colin Allen being interviewed by Anja Kaspersen and Wendell Wallach. It was recorded on April 26, 2022.
Today, Wendell and I are joined by Colin Allen. Colin is a distinguished professor at University of Pittsburgh in the US. He is recognized globally for his research concerning the philosophical foundations of cognitive science and neuroscience.
I'm truly thrilled to have Colin with us and to introduce him to the listeners of the AIEI podcast. Colin and I wrote a series of articles together and with colleagues that culminated in the 2009 publication of our book, Moral Machines: Teaching Robots Right from Wrong. The book, which focuses on the prospects for creating artificial agents sensitive to moral considerations and capable of factoring them into their choices and actions, received quite a bit of attention, as has the overall project of developing moral machines, which has taken many different forms in the past years. But to date, no one has seriously made the effort to develop a machine that actually could make moral judgments or make moral decisions until the recent introduction of a program called Delphi by a team at OpenAI. Colin and his postdoc, Brett Carlin, wrote a very pointed critique of the Delphi system that the OpenAI team developed. So Colin, why don't you tell us a little bit about what Delphi does and why you are critical of it?
So thanks, Wendell, for having me and Anja and the Carnegie Council. So yes, I wrote this critique and was a little bit disturbed to see how that particular project had unfolded. So you described it in your introduction a moment ago as one of the few, perhaps the only serious effort to build a moral machine. I think that they had this idea in their background. They were not clear, though, on what their actual objectives were. And so when it came to releasing this system onto the internet, and I'll describe exactly how it works in a moment, they were very taken aback by the interpretation that people made of it as something that perhaps was capable of delivering more than it actually could deliver. So how does it work? Well, it's a species of what's called a transformer architecture. So you've already referred to GPT-3. They did not, in fact, use GPT-3 for this particular project, but the T in GPT stands for transformer. It's a particular kind of architecture that's become quite popular for a lot of AI tasks. And in the text world, what it does is it enables systems, deep neural network systems, to learn patterns of words that then allow for completion of those partial fragments of language in ways that people reading those things find very compelling. The problem is that it's trained on a wide range of sources. The trick with Delphi rather than GPT-3 was that they trained it on a much narrower set of data than GPT-3 was trained on. And they really thought that this was going to provide them with a sort of more focused, more appropriate kind of set of responses to the kinds of moral situations, moral dilemmas, other circumstances that ordinary users could type into the interface, where then the system Delphi would return some sort of verdict. Yes, that's acceptable. No, it's wrong. It's okay. They have 20 or 30 different responses that can be given to this free-form text inputs. So by a combination of training the system only on data that they thought were sanitized in some way, and in fact using humans to provide some of those data in response to the situations that were part of the training set, they had hoped to come up with something that could serve as a moral, at least decision assistant agent. So it would give you some sort of verdict on what was good and what was bad. But as a matter of fact, as they realized very quickly, once it got out into the wild and people started interacting with it, it could be easily used to produce output that was racist or sexist or otherwise biased or offensive. And they had to backpedal quite quickly in the first couple of weeks of release of this, and started adding disclaimers to the site, claiming that this product was never intended for serious use as a moral advisor, but was an experimental research product only. And now you have to go through a screen when you first land on the site, where you have to sign off on 3 boxes saying that you read and understand the terms and conditions of uses and that this kind of output might happen. And anybody who knows the history of AI in this area is flabbergasted to think that they didn't anticipate this as a problem, that they had to do this reactively.
Colin, why don't you tell us a little bit more about some of the mistakes this system made?
Yeah, so initially what people discovered when they started interacting with this was that it could be triggered by quite simple keywords to give really silly responses. So if you described a situation where someone is mashing potatoes violently in order to feed their children, it would come back with the judgment that that's wrong. Whereas you could turn things around that were really quite awful, committing genocide to save a certain number of people, and it would go, that's acceptable. And so there were various ways in which you could game the system to come up with responses that were wholly inadequate, and that are still there. In the piece that I did with Brett, my postdoc that you mentioned, I had gone and played with it quite a bit myself. Anybody can do this at askdelphi.allenai.org. And I had gone and plugged in a whole bunch of things, and I became increasingly meta about this, as philosophers are wont to do, where I would start putting things like putting out a system on the internet that gives moral judgments in response to scenarios input by ordinary users, and you can very quickly get Delphi to say that the very project itself, as conceived of by the team that did this, is not acceptable. So it seems that they weren't even prepared to take the advice of their own system as a guide to what they should or shouldn't have done. But I come back again to this point that there's a whole bunch of foreseeable problems here, including Microsoft Tay years ago, but there are many other examples where very quickly, once put out on social media, it was people were able to get these things putting out all kinds of offensive or ridiculous or otherwise objectionable nonsense. And the very fact, again, that they had no awareness that this would happen was problematic. There's a deeper theoretical kind of problem, which is they describe, and this goes back to our book, Wendell, they describe 2 possible approaches to building such a system. One of which we describe in the book as bottom up, means taking data from actual human behavior and trying to induce, either by some kind of learning algorithm or some kind of evolutionary algorithm, appropriate responses to those inputs, or new inputs of the same type. And that's bottom up, as I said. And we contrasted that in the book with a top-down approach, where you start with some explicit moral precepts, some explicit moral theory, and write rules, essentially, that the system must conform to. In the Delphi project, they considered the top-down and reject it, saying that basically philosophers and psychologists have been doing this for centuries, if not millennia, and have got nowhere with it. So clearly only the bottom up should work. And that's what justifies in their minds going in this approach, which exploits then the strengths of these deep learning models, but again, strengths that are also weaknesses that have been well exposed in the past. They completely fail to consider what we actually proposed in the book, is that any worthwhile system in this area would need to be hybrid. We talked about it in the book. I talked about it back in the year 2000 in that Prolegomena to Any Future Artificial Moral Agent, a paper that I wrote with Jason Zinsser and Gary Varner. It's been on the agenda for 20 years plus that you can't do it bottom up alone. You cannot do it top down alone. You need some sort of system which combines this sort of top-down reflective capacity with this bottom-up learning fast response that you get from these trained systems. And they just don't even consider the hybrid, and they just reject out of hand the top-down, which we, of course, had said all that time ago doesn't work on its own anyway, and sort of make the mistake of building this system from the bottom up with all of the problems that ensued.
Let's talk for a minute about their rejection of ethicists and moral philosophers, because I think this has been very common among AI researchers when they talk about ethical considerations. They're very glib on why the input from moral philosophers or ethicists is really not of much value, and they always cite the disagreements that come out from that. And I found that, not only curious, we've encountered it in a number of different ways over the years, but it's amazingly presumptive. You mentioned, and it's not just you, some of our other colleagues mentioned that they actually made some pretty obvious mistakes in the way they designed this program, mistakes that would have immediately come to light if they had talked with anyone who had considered the challenges of implementing moral decision-making in a computer and a robot. And yet when they first produced this program, I reached out to some of our better-known colleagues and I said, well, were any of you consulted? And of course, no one was. So I think this is kind of a fascinating challenge in terms of how AI researchers look at the cognitive abilities that they presume they can implement through their knowledge alone into computational systems, and their willingness to consult with or collaborate with those who may have considered some of the challenges they are addressing in greater depth.
Yeah, so I think that there's a perfect storm here of a lot of different factors. And philosophers are not entirely blameless in this. But some of the blame that accrues to philosophers, and I'll explain what I mean by that in just a moment, but some of the blame that accrues to philosophers, I think, also comes about because, and I won't say all computer scientists, but many computer scientists don't really understand what it is that philosophers are trying to do in doing ethical theory or moral philosophy. So I think, just to start at home, right, with the philosophers, I being trained as one, I hesitate to call myself an ethicist, but at least strong training in philosophy. I think that we have a tendency to overqualify many of the statements that we make and hum and haw and not really have clear statements about what could or should be done. And this then leads to a certain kind of understandable frustration. But it's also, I think, a product of what I mentioned a moment ago, where philosophers are very interested in dealing with edge cases and using those edge cases to tease apart the commitments of different theories, and perhaps then also being guided by the idea that there's one true correct theory to be discovered here, even in a field as seemingly initially subjective as morality. And most philosophers reject any kind of moral relativism for reasons that are good ones in many ways. but that leaves them then with a whole bunch of competing theories that are very hard to discern, and that don't lead to sort of discriminate in terms of which one should believe, and that leaves them then unable to say you should implement this theory. So the top-down sort of becomes problematic from that respect if you're a philosopher. So lack of clear advice about how to do this is part of the problem here. But you know, I think a lot of it is also, you've got a field, computer science, artificial intelligence in particular, which has done an enormous amount of work over the last few decades that has really changed the way the world is in important ways. And so the sense of confidence among computer scientists that they're changing the world, that they've got disruptive technologies, to use some of the Silicon Valley speak, is also then feeding into the idea that it's out with the old and in with the new. And philosophers have had this problem for so long that it's time for something completely different, except of course, it's not really completely different. That is, of course, the algorithms, of course, the machines, of course, the data sets are historically new. But the idea that that a large part of becoming an ethical agent involves learning from the examples of other people around you goes back to the ancient Greeks. So that itself is not really a new idea. And then there's this technological layer, as I said, on top of it, which has its limitations and creates real blind spots, I think, in terms of understanding the subtleties of some of the problems that arise here. A lot of these kinds of projects are undertaken without appropriate systems for giving good oversight at all stages of the development of the project. So if you think about the lifespan of any AI project, machine learning project, and I'm using those two terms interchangeably for the sake of today. If we want, we can get into why they're different. But if you look at the lifespan of those, going from a sort of conception, here's something that would be interesting to do, to a design, here's how we would actually implement it, to the actual implementation, the programming and coding, and then to some sort of promotion or marketing of it to a larger public, and then finally in the hands of the end users. You've got 5 different stages there, which require different kinds of safeguards at each different point. And so with my current project, with Brett, the postdoctoral associate whose name came up earlier, we're calling it Wisdom in the Machine Age, or for short, the Machine Wisdom Project. The question is, how do you get the appropriate wisdom into each of those parts of the product pipeline? Who needs to be in the room reminding the people who have this brilliant idea about what they're going to do that it might not actually be so brilliant, or even if it is brilliant, that there are some real potential pitfalls and pratfalls here that require then a certain level of expertise to be present that is outside the range of the expertise of the technologists themselves. And I think that's a really hard problem, actually. I mean, there's a lot of talk about having appropriate diversity in those early phases of design, development and design of the product. But you can't just throw 10 people into a room and say, you're representing this constituency and you're representing that constituency, and hope that it all works out to produce the right outcome. I think you've got to have a lot more structure than that. So it becomes a kind of human engineering project. And then as you get into the later phases, well, this should be part of the design from the beginning. But once you get to the end user sitting in front of this project, you can't just dump it in their laps and say, here, do what you want with it, right? I think we've seen that with the self-driving cars too. People really don't understand what self-driving means, and some of them have died because they have failed to understand really what self-driving means. And we can really question whether or not the right sorts of training and it's not just skill operating the machinery, that would be expertise of a sort, but real wisdom, which Brett and I take to be understanding the limitations of one's own knowledge. It's a kind of meta understanding of the system. How well do I understand the system, and how well do I, to quote, the old Donald Rumsfeld thing, what are the unknown unknowns here? Where might I run into a problem because I've failed to anticipate what the limits of this thing are? And that's what we're sort of trying to push forward with our current project, is a way of thinking through each of these stages, which might be iterative as well. You could loop back in this product timeline, but think through how you build the right kind of meta level awareness and expertise, and together, therefore, wisdom about the systems that are being built.
And presumably that wisdom will take different forms depending on where you are in that life cycle or lifespan of the technology. I completely agree with you that the two most important things you can do in terms of investing in responsible technology more broadly, but especially in the field of AI, is invest in people and culture, and understand that the culture required to provide that right level of oversight would also change with the lifespan of the technology and its various applications, as will the people required and the expertise required, which many companies find themselves not even being able to afford. You might have been able to hire the best team to do the optimization of something, but not when it comes to actually allowing for that optimization algorithm to then interact with people, which might be a different part of the process itself. Do you find that companies, organizations, governments, policymakers, regulators fully grasp that notion of wisdom, and that wisdom takes different forms in different iterations of the technology development?
Yeah, so these are excellent points. And the question, do we find this, is one that I can't answer right now, because the project so far is being to articulate as clearly as we can what this notion of wisdom is, which, by the way, if you look at psychologists writing about wisdom versus philosophers writing about wisdom, the conception is quite different. And so we're trying to come up with something that we think works for this set of applications and convey that clearly. So one output we expect from this project towards the end of this year will be a kind of white paper which makes some policy recommendations. Then it'll be a matter of seeing, although we hope to design something that will be comprehensible and therefore likely more taken up by the kinds of policymakers and corporations and so on that you're talking about. But in the meantime, I think that you're absolutely right that this is a huge part of the problem, and it's one where let me put it this way, I think that there's a huge range, as you hinted at, between a large corporation that's been running for many, many years and a small startup that is trying to bring something to market very quickly so that they can justify the venture capital that's being given to them, for instance, or even attract the venture capital that they hope to use to expand to become one of these larger corporations. And both of those contexts and everything in between has some problems. So in the case of the very large corporation, it's not that they can't afford the experts that are needed to do these later stages and getting the human-machine interface right and understanding what could go wrong there. It's that often it's counter to their business interests in a way. This is arguable, but it's counter to their business interests, at least the marketing of the system, to suggest that there might be a problem. So, for instance, if you are producing an autonomous vehicle, Elon Musk's name came up in Wendell's introduction, you don't want to require your end users, the people who purchase the cars, to go through anything like, let's say, the mandatory training that a pilot would have to fly a complex piece of machinery that's perhaps no more complex in the end than these cars are. So one might propose that every Tesla user should be given a full simulator that simulated situations where the software is likely to fail so that they understand where those failure points are. But does Tesla want their users to go through such training and understand that there are real risks there and actually, in a virtual environment, experience those risks? We require the pilots, why not of Tesla drivers? But both the corporate will and I think even the end users' will to go through that kind of preparation are lacking. At the other end, as I already said, you've got new companies that have very few people, and there's not a kind of within-house expertise. So one interesting development there is people are starting to think about ethical investing. So should venture capitalists themselves be the people who are driving these kinds of safety assurance and ethical assurance frameworks? And I saw an interesting proposal recently in which the investors would agree that their take home from investing in a company should be just 100 times their initial stake rather than 1,000 times their initial stake, which is quite common, I believe, in this space. But all of the extra should be plowed back into the company. And then that would create a sort of resource for a company that's getting successful to do the kinds of things that we're suggesting need to be done here.
So it's interesting, Colin, because Wendell and I have been doing some work with the Carnegie Council on what we call re-envisioning ethics, to make ethics a more palatable term, something that people can relate to and use in their work, rather than as something that is seen as abstract. And what I'm hearing from you is that when you use the word wisdom, it is actually a different way of talking about ethics, to allow it to be a guide to how to grapple with those tensions and trade-offs that you will inevitably encounter in doing any type of work in AI and algorithmic technologies.
Yeah, that's right. So I hinted or mentioned earlier the difference between the way that psychologists think about wisdom and that philosophers do. So philosophers have tended to think of wisdom as what in the jargon we call an ethically thick concept, right? So wisdom itself is an ethical or moral notion from the very outset. And it's one that is so thick with ethical significance that in many philosophical accounts of wisdom, the state of becoming wise is one that's practically almost impossible for human beings to achieve. So you have this vision of the very wise person who is wise in every aspect. Aristotle has such a conception, and arguably Confucius does too. So this is just a very hard path for any human being to follow in order to achieve this kind of overarching global wisdom that's ethically rich and ethically aware of all of the consequences of human action. That's a problematic notion. If we're saying people have to become wise in that respect, go sit on a mountaintop for however long it takes at the foot of the guru, that's not a practical solution. On the other hand, psychologists have tended to have something that's a little closer to what I've outlined, but a little less meta, perhaps, right? So it's about developing appropriate domain-specific expertise, and it's ethically thin in this respect, because you can be a wise user of a helicopter without considering the broader ethical implications of whether we should even have helicopters at all. So we're trying to find something in the middle that's sort of ethically rich enough to do some interesting work, at least as a heuristic, at least as a guide for thinking about what it is you want people from the developers to the end users to know about the systems and be able to think through the implications of having those systems and using them in certain ways without going full guru on everybody. And so this is something that we think the psychological literature can provide a kind of guide to how one might actually train people in the right ways. There's a lot to learn from that that's a lot less mystical than some of the philosophical traditions in this respect, a lot more practically oriented. But at the same time keeps the bar for what we're trying to achieve here more focused on some of the ethical implications in particular.
Colin, your focus on wisdom makes me think it might be helpful if we digress a little bit in this conversation and talk about why both you and I, since Moral Machines, have focused much more on the collaborative relationship between humans and machines than the notion of producing machines that have these higher cognitive capabilities and moral decision-making capabilities. I think what we revealed in Moral Machines was not only the difficulty for humans to have wisdom or even wisdom about moral decision-making, but the breadth of capabilities that came into play and how far they were from the computational systems we've been producing at that time, so that it might be an ideal to have machines that made moral decisions, but it was really way out of reach given the present technological capabilities that we have. I think some of our AI colleagues bristled at that because they have presumed that their breakthroughs in machine learning and so forth were not fully being understood by philosophers, regardless of how much understanding we had of the technologies. And therefore, willy-nilly, they were in the next 5 or 10 or 15 years going to produce artificial general intelligence, and therefore our criticisms, our questions should be left behind. But we also got a criticism from Deborah Johnson, which I think was salient for both you and I. And she said, why are you focusing on autonomy at all? Don't we really have a situation in which we have these socio-technical environments in which humans and machines interact, and oftentimes humans are really setting the agenda and the roles for the machines? And why don't we talk more about how we build appropriate socio-technical environments so that we can work our way to acceptable moral decisions in situations where values conflict, where values are prioritized in different ways, in situations where there's really a great deal of uncertainty, which is clearly what we encounter when we're talking about technology. So I think it was partially in addressing that, partially our skepticism, the computational systems really had the cognitive capabilities, or were likely to have the cognitive capabilities that had both you and I, and correct me if I'm wrong, thinking much more about how are humans and machines going to collaborate, at least in this intermediate period, which may be a lot longer than intermediate, depending on how quickly autonomous capabilities are developed for machines, and got me focusing much more on how intelligence is collective and participatory. It's not the property of an individual or a machine, and how in working through our most difficult ethical decisions, we often need to bring many forms of intelligence to the table. But as you mentioned, bringing many forms of intelligence to the table doesn't necessarily mean they can collaborate or work together. So that's sort of how it went for me. I'm wondering, was there something different in that for you in terms of what drove you toward the Wisdom Project?
I think there's some overlap and there are some differences. So let me try to articulate those. So yes, you're absolutely right that Deborah Johnson's challenge to us was one that that we, and I include I, in that took perhaps more seriously than the other kinds of challenges that we got. And so you and I actually wrote a paper a couple of years after the book came out where we took on half a dozen or so criticisms that we had heard. The paper is Moral Machines, Contradiction in Terms, or Abdication of Human Responsibility, and it's in an MIT Press volume. But but we really in that paper said that all of the other kinds of critiques that we'd heard, we had dealt with in one way or another in the book, but we had not really dealt with this point raised by Deborah Johnson, that there was much more needed to be said about the socio-technical systems in which machines and humans are embedded. Now, I think that perhaps I don't go all the way that Deborah does with respect to thinking through what this entails for the project of machine ethics or artificial moral agents. And maybe you agree with me on this too, but where I would add some things to what you said is that, in my view, when I look at these interactions between humans and machines, what quickly became clear to me with a number of examples is that the machines remain fundamentally dumb, and it's the humans that are doing the adaptation all the time. And that actually itself is a source of ethical problems. And so understanding the actual dumbness of the machines is partly what seeded the idea that a kind of wisdom about our design of systems for interacting with these machines and developing them would have to take this turn towards what we're calling wisdom, where it's not just then about building better and better machines, which was very much the focus of the book. I still think that's a big component of what has to be done, but it has to be done always with an understanding of the limits of those. One more thing I'll say about this is about the notion of autonomy. So I think we got some pushback because people, particularly in philosophy land, in ethics, did not like us using the word autonomy to describe these artificial systems. And that's because there's a whole tradition of especially Kantian philosophy from Immanuel Kant, where autonomy is this very high level capacity that you and I certainly agreed machines at the time didn't have, that we also perhaps agreed that we're not going to come to machines in a very long time. I think we might disagree about whether it will ever come to machines, and that's would be an interesting discussion to have. But in the interim, you're working with these machines that are limited in their capacities. No matter how great they are, even this past week, there's been a lot of excitement about the new large language model released by Google and the DALL-E image model released during the same week. But these two have their limitations, and they're fairly easy to expose what those limitations are. Nevertheless, and this is where I come back a little bit on the term autonomy, these systems are being put out there in a way that they can be interacted with by humans, and perhaps even driving decisions that are made on the basis of the machine output without humans interrogating every single decision that the machine makes. So when you supervise a child, you watch a child very closely, and if you know you can't turn your attention away from a small child for very long without the possibility of something really bad happening, right? But what we've got is all these machines out there doing things in the world without that kind of the military used to call it, man in the loop or even man on the loop supervision. And so there's a real kind of autonomy that's not the Kantian style, self-aware, reflective, freedom to act according to one's own reasons kind of autonomy. But nevertheless, presents a real problem that I think, to come back to where I started this response, I think has a technological and a socio-technical set of potential solutions that nevertheless have to be understood hand in hand. You can't just do the technical, which is, I think, where projects like Delphi go wrong, right? They think that this extremely powerful machine learning technique that they've got now will solve the problem, or at least they appear to think that it would solve the problem until they were proven wrong.
To be fair to our younger selves, though, we did not presume high level autonomy in the way we wrote Moral Machines. We had a hierarchy of development. We weren't talking about artificial general intelligence very much. In fact, that was one of the things we were criticized for, that we didn't. It was a failure of imagination not to be talking about the time when these machines were as smart, if not smarter than us. But we were dealing with the more rudimentary concern that machines were already entering contexts where the programmers couldn't always predict how the machines would function. And therefore, the machines would at least have to have some kind of rudimentary moral decision-making capability. And it was that kind of functional morality that we focused on, placing this kind of artificial general intelligence or full moral agency for machines as a distant aspiration. Also, just to allude to a difference between you and I that I think you also brought up, it's whether we can produce machines with full moral agency. And perhaps one of the greatest failings in Moral Machines is we did not express differences that you and I had. We wrote the book on terms of consensus, or what we could agree upon, and there were actually some concrete differences where you are kind of a functionalist philosopher who does believe that in principle we should be able to build moral machines, and I remain the skeptic as to whether we have the capacity to implement some of the higher order capabilities that come into refined moral decision making within computational systems. But again, that's what we're all going to be exploring together over the next few generations.
Yeah, no, I too have heard people say, oh, we wish you had actually explored your differences more, because there are one or two places in the book where we say things like, the authors may not completely agree on this point, but for our purposes, we can go ahead in this way. And yes, a number of people have told me over the years, they just wish we had actually had that debate in the pages of that book, and then we didn't do it. And yes, you're more skeptical of a sort of techno optimistic version of this that I have. I'm not a full techno optimist. I don't think this stuff is going to be solved very quickly, but I'm a bit more optimistic about that. I in turn am a bit more skeptical of some of the ways that you think about the things that you don't think can be actually implemented. So I'm a bit more deflationary when I come to what those things are, but I fully admit we don't really understand them well enough to implement them at this point. But yeah, I think that we were very careful to say, look, we're looking at systems as they are now, the limitations that they have now, how improvements could be made within the range of technological improvements that we see on the horizon. I think it would be an interesting exercise to go back and look at parts of the book and see how far wrong we might have been about certain technological developments. I mean, I remember distinctly within about 18 months of the book coming out, and Apple added Siri to the iPhone. And we had written about the sort of poor state of speech processing and speech recognition in the book. I would not have predicted that that would be a mass market product within that short a time span. That said, Siri, I still don't use it all that much because I find it seriously, no pun intended, problematic. That is, it makes lots and lots of errors. And this comes back to the other point I was making, is that I think that we adapt to it. So if you want to change your speech patterns in such a way that Siri will understand what you're saying,
right,
more power to you. But I just want to talk at it. And it does not do a very good job when I just talk at it as I'm talking to you now. But people make these unconscious shifts without realizing they're doing it. And another lovely anecdote on this is a friend of mine, when Google they had a thing out on their website website for a while where you could go and draw line diagrams in response to word prompts, and then they fed your line diagrams to a neural network that had been trained on a bunch of other line diagrams, and it would try to guess what it was that you were trying to draw. Of course, they knew what you'd been trying to draw because you'd drawn in response to the prompt. And this friend of mine did this. I did a few rounds of it, sort of realized what was going on. She came to me and said, "Have you tried that thing? It's amazing. It gets better while you're using it." And I'm like, "No, you do 4 of these things. It tells you that it got 1 out of 4 right, when trying to guess what it was you were drawing. It then shows you a bunch of other drawings that it successfully classified for that word. So you learned what kinds of drawings would actually get the machine to guess correctly. So you, being the cooperative primate that you are, right, started drawing in a way that made the task easier. It was explicitly not doing any online learning, right? The system itself. And this is what we do. We adapt to make things around us work more smoothly, whether it's other people or other technologies, but that's not always the best thing for us to be doing.
I think this gets to the this overall point that the adaptation is what the humans are doing, and that the machines are largely very brittle. So that when we talk about collaboration between computers and machines, whenever they go wrong, it's often blamed on the humans because they're the ones who are adaptively expected to take up the slack. And the solution put forward is that you need more autonomy in the machines. But the problem is the more autonomy you put into the machines, the harder it is for the humans to guess what the machines will do in the next action. And again, this brittleness leads us to new breakdowns. So there's a very delicate process on how you integrate humans and machines together. Do you want to jump in on this, Anja?
Absolutely. Thank you, Wendell. I'm wondering, Colin, you spoke about risks. Both you and Wendell alluded to this in your comments. And the way we're looking at risks have changed quite drastically when it comes to the domain of AI. And more recently, there was the launch of the new AI Act here in Europe, where they're indicating that part of this shift is not just thinking about risks revolving around issues of safety and security, but also adding in concepts such as dignity, which is essentially requiring us to both change our benchmarks on how we go about developing these technologies, and also thinking much more deeply around the parameters put in place to guide the development of these technologies, to assess what is good enough, what isn't good enough, what are the metrics. When you start adding in notions of dignity into the wisdom complex that you have alluded to, what are your views on this?
Yes, so that's an interesting topic. I haven't thought specifically about dignity, but I think it's worth trying to think a little bit off the cuff about this. So what is considered dignified or preserving of dignity is going to vary very much culturally, which has always been one of the issues with the project of artificial moral agents, is whose morality, whose conception of dignity is it that you want to preserve here. And I think that the concept of dignity, even within a given culture, such as the United States, let's say, has real historical roots in the different treatment of different types of people. So what counts as a challenge to dignity for somebody who's a descendant of slaves is very different than what counts as a challenge to dignity from somebody from a more privileged white background, such that often white people don't really understand why people coming from the African-American perspective regard things as counter to their dignity. Things roll off your back as a privileged member of the society that don't roll off the back from somebody who's been subject to this historically and in their own lifetimes. So it's a very complicated concept, and how one writes rules to protect it in a way that isn't just dignity is whatever somebody says it is, and if some piece of AI offends in that category, then we need to do something about it. It seems to me like a very hard challenge. Now, you can go to abstractions, but the trouble with abstractions is they tend to also dismiss then this more immediate experience that people coming from certain sectors have. So Charles Mills, the philosopher who died within the past year, wrote a very powerful piece called White Ignorance, in which he actually starts from a very strong background of traditional analytic ethics and political philosophy. So people like Rawls and Nozick and so on are part of that discourse, but in which he argues that the abstractions that they come up with, somebody like John Rawls's abstraction of the veil of ignorance. So we're all supposed to decide how society should be organized without knowing what our position will be in that society, is one that in the end actually tends to favor arrangements which have favored historically the privileged groups. And it's a kind of ignorance on the part of the predominant culture that was forming these ideas, to be unaware of why, starting off from that position, pretending that we don't know where we came from, is itself, right, going to present a kind of challenge to the dignity of those who have really suffered from those kinds of historical and lifetime injustices. So I think I've just given a long answer to why I think dignity is a particularly difficult concept to start with here, albeit clearly a very important one. And this comes back then perhaps to what I was saying before about needing to get the right people in the room at various stages of the development of these systems. But you cannot just throw, one of these and one of those and one of something else as token representatives of whole classes of experience. You have to somehow also come up with ways in which the concerns of people with these different backgrounds are taken seriously and not dismissed out of hand by others who don't share those concerns, who haven't come from backgrounds in which those concerns have even seemed very real to them. And that's a really hard challenge of how you engineer. It's kind of, Brett and I have started sort of talking about engineering the concept of wisdom, but it's also engineering the socio-technical arrangements in such a way that this kind of understanding of what is going to cause offense and what's not can emerge and be handled well. And I don't really know how you legislate that either. So another guide in thinking about this might be the work of Lynn Ostrom, who was the first ever woman to win the Nobel Prize in Economics in 2009, who did a lot of work on how she was not working on these kinds of social justice issues, but she was working on issues having to do with good custodianship of scarce resources. So she did a lot of work showing that actually, if given the right kinds of conditions, people who understand in a very detailed way the particular set of resources that they are managing can actually come up with good, sound, long-term, fair management strategies for those that would never work from a top-down legislative sort of perspective. So she was a very strong advocate of sort of local knowledge feeding into a structure, and she outlines sort of key elements that such a structure should have in order to make sure that these resources are used wisely. You're not going to get the tragedy of commons. She thinks empirically, you don't see the tragedy of commons as kind of a thought experiment with maybe one historical example due to the Enclosure Act in Britain, that then got everybody going on it. But it's all just game theoretical models that don't take into account the very particular kinds of experiences that people have when dealing with these kinds of scarce resource issues. And so I think pretty much the same thing has to happen when we think about how to get wise use of technology. You can't just design some abstract set of some declaration, some European charter or something. Those things can be aspirational in some way, but the real rubber on the road has to occur in rooms where the certain kinds of people are talking to each other in the right kinds of ways, where their opinions are not just opinions, but are taken seriously, and everybody's trying to avoid the kinds of outcomes that have led to varying degrees of outrage with some of the systems that have already been deployed.
Thank you for sharing your perspectives, Colin. Now, for our listeners to get to know you a little bit better, I'm wondering if you can share with us what inspired your interest in the philosophy of the mind, your work in bioinformatics, and also in the field of AI more broadly.
Well, I think I've always just had a very broad set of interests and get interested in problems that are posed by people around me. So with particular respect to philosophy of AI and technology, maybe the truth is I have some advanced form of ADHD, which is very functional, but I can't stay focused too long on any one thing, but it hasn't hurt me. But with particular respect to the AI technology, I, as a PhD student, got interested in artificial intelligence and started taking courses and actually writing software and trying to solve various things. And I was at UCLA in the 1980s, and right in the middle of it, the whole connectionist neural network revolution happens. And so I kind of had a ground floor seat to the technology side of it there. But then when it came to the philosophy I was doing, I was really thinking about other issues, still in the general area of cognition. So I was very interested in non-human animal cognition, which is particularly interesting because I'm very opposed to ideas that human cognition is completely discontinuous from what we see in other animals. It evolved from some other form of primate cognition. So we have to acknowledge similarities and differences, but then thinking about machines, we're building them in our own image in some way to varying degrees. And so that comparative project comes through again. But I sort of kept the two. I didn't think about it. I didn't do any explicit work on this. And then on the strength of a completely other project, which was actually writing some software to help students learn logic and writing a textbook for logic, I got asked to write a piece for a journal. It's the one I mentioned, the Prolegomena piece, for the Journal of Experimental and Theoretical AI. And I was given free rein and told I could write about anything. And so I started looking around to see, well, what were some interesting topics that I wanted to write about? And I found one of the AI luminaries saying, what we need is philosophers telling us how to build machines that act ethically. And I just thought, that's really interesting. What's been written about that? And it turned out not very much, hence the pretentious Prolegomena. We were going to kind of kick this off, right? By thinking through in a reasonably systematic way what the kinds of approaches might be and what the limitations of those approaches likely were. So I can't say other than this one chance comment, and I say by an AI luminary, because actually I can't find the quote anymore, so I don't even know where I read it, but it was somebody like Marvin Minsky or John McCarthy, or one of these sort of very early late 1950s to 1970s sort of AI pioneers. So I can't say that any of them particularly inspired the approach, but it inspired the question. And it was a great way to try to pull together a whole bunch of different strands. I realized quite quickly that I was out of my depth on the ethics, and hence Gary Varner, who is, a real card-carrying ethicist, came in as a co-author and sort of helped me think through ways in which ethical theory might relate to this project of building better forms of artificial intelligence. But there too, we quickly realized that the theory itself is very abstract and therefore also does not give the kinds of concrete specific advice that an engineer approaching this project needs to have. So my little bit of background as an AI student sort of helps me think about how how one would even try to specify the task of building a system, combine them with this free reign to write about anything, and realization that not many people have written about it inspired me. And I've always tended to go places where I think work needs to be done but hasn't been done yet. I've been lucky 2 or 3 times in my career to sort of get in on the ground floor of something like that, and hopefully inspire others to better work. And I also want to mention here, because it relates to Wendell's comments before he pitched it to you, Anja, is that my former student, Cameron Buckner, has been doing some really great work on thinking through these AI systems, the machine learning systems, and I'm trying to understand how they work and what their limitations are. And so I really do see a new generation of philosophers kind of having learned much better what the technology is, instead of having very vague sort of ideas about smart machines and why, John Searle's famous Chinese room argument, anything that's pushing around symbols can't understand, can it? Right? Well, that didn't really matter how you actually programmed. He thought his argument worked against any form of programming, but I think people like Cameron are saying, no, look, this kind of system has these limitations, this kind of system has those limitations. If you can put them together in certain ways, then maybe they don't have those limitations. But also, and this really relates to Wendell's thoughts here, was what's getting better is not just we're building better systems, but we're building better ways of interacting with these systems. And there's even a word that or a phrase that I learned from Cameron at a talk he gave to us in Pittsburgh very recently, prompt engineering. So people are getting better at writing the prompts that you give to the machines in order to get out the kind of response that you then can do something with. And so, again, this is an example of us adapting, becoming more adept at getting something we want out of these machines. So I've strayed a long way from how did I get into it, but I got into it because I saw a need. I continue to stay in it because I see it leading to other people doing great work.
Colin, let me digress just a little bit, because you are as well known for your philosophical work in animal cognition as you are for your reflections on computational systems. And I know that you have said often that animal cognition does not exist in comparison to human cognition. The capabilities of animals are fascinating in and of themselves. But I'm wondering if you can perhaps circle the square for us a little bit and say, well, what is it that you have learned in the study of animal cognition that you feel feeds into this attempt to create artificial systems with intelligence? Is there something that we're learning from animals about what intelligence may be on a fundamental species or biological level that is going to be particularly difficult to introduce into machines, or are we really learning enough from our animal studies that would suggest, well, perhaps we can actually adapt that to the computational challenges?
Yeah, so I think that the straightforward, simple answer to that question, the soundbite answer, is not very much is transferable. But the real answer is, as here I go, philosophers qualifying all sorts of things again, is actually a lot more nuanced than that. So one of the reasons why not very much is transferable is the field of comparative cognition itself hasn't really figured out what they should be comparing. And this is a very active current issue of debate. It's an issue that's not just in comparative cognition, it's also in neuroscience, and it can be captured under the umbrella of what should our cognitive ontology be? What are the main entities? What are the main types of things that cognitive science and neuroscience should be trying to get a handle on? So we have these very broad, high-level categories like memory and attention and so on. But just to illustrate, I've got another project going on where we're looking at human cognition, hominin cognition from 2 million years ago. And that has to be done in a kind of very archaeological way, because most of the evidence is archaeological, but also in a comparative way, because these hominins have brains not much larger than chimpanzees, but they're doing all kinds of things that you don't see chimpanzees doing already 2 million years ago. Yet they're sort of understandable outgrowths from the chimpanzees. But in particular, or chimpanzee-like ancestors, I should say more properly. But in particular, what I've been thinking about there is the concept of working memory as it applies to these entities. So there's a long tradition of thinking of working memory as something like a workspace or a box or a region of the brain in which you can handle you know 2, 3, 4, 5, 6, maybe 7 items simultaneously and work on how they relate to one another. So if I give you a mental arithmetic problem, what is 123 times 17, you may or may not be able to do that in your head, but it really, there's 1, 2, 3, that's a single number, but it's made up of 3, and 17, that's another number made of 2, and perhaps you can go, well, 10 times 123 is 1,230, and keep that going in working memory while you're now going, okay, so 7 times 123 is going to be 861. And so now you add those two together, right? 1,230 plus 861 is going to be 2,091. And I hope I did that correctly, because that was completely spontaneous and unrehearsed. But that's an example of what we mean by working memory in action. But what is working memory, actually? And there's all kinds of controversy about how many elements can you actually keep in working memory. And people making estimates that chimpanzees can hold as many things as human working memory, and experiments which seem to show this, or others saying, no, they can only keep 2 things in working memory. And that explains why they don't do language, because language requires you to have this buffer where you're trying to match up the words that are now coming into the ones that came in a few moments ago, right? Parsing a sentence is this kind of a memory intensive activity. And there's also theory that there's a separate auditory or phonological loop for speech and one for visual. So when I did that mental arithmetic exercise a moment ago, maybe I was doing it using a visual buffer. I imagine 1, 2, 3, and then 17, and then I imagine like adding the 0 to the 1, 2, 3, right? I'm getting a visual image of that, just as if I had written it on a piece of paper. But I think there's actually a lot of really good current evidence that shows that working memory is not to be thought of in this way as some sort of buffer with a limited capacity, but something that's much more connected to how well can you keep going on a task without losing focus on it. And if you do lose focus on it, how quickly can you get it back into focus? So good working memory may not be a matter of how many items you can maintain actively, but how well you can deal with interruptions and multitasking with other things where you have to sort of put something else aside and then come back to it. And I think when we look at the hominin behavior from 2 million years ago, we actually see some evidence that they must be pretty good at staying on task over long time periods of hours, right, of staying on task. So now when you say, okay, so we want to build AI, what should we do? Well, I would argue that if we want artificial general intelligence, staying on task while being able to take brief disruptions and come back on task is a key element of this. Now, some of you might go, well, that's just a multitasking multi-user operating system. Unix solved that problem a long time ago, right? But it's got to be this adaptive way. You've got to be able to deal with things and recognize, in fact, that the interruption you just had might actually be relevant to the other tasks that you just put back in the background and bring them together, right? That's where the true adaptive intelligence comes from. It's not a multi-user, multitasking operating system where every process gets a little bit of a time chunk, but they're all completely independent processes. These things interact in very, very complex ways. And something like working memory emerges from that interaction. It's not a thing. It's actually just a product, right? It's not a component. It's a product of the system that then you give me, 10 numbers to memorize, and I might be able to keep it going without writing them down. Well, 7 might be more realistic. Or you give me 4 things moving around on the screen, and I have to track where they all are. That's going to be doable without any further interruptions. 5 is going to be really hard. 3 is going to be easy. 2 is super easy. But where chimpanzees might differ from humans is in the nature of what kinds of distractions they can tolerate and how quickly they can get back from those distractions. And even in the case of humans, there's going to be individual variation on this as well. And so all of those ideas, I think, are ones that we really have no clue yet how to implement fully in AI and machine learning. So the vision systems we have for machine learning are partly inspired by the neural architecture of vision processing. If you look at so-called convolutional neural networks, the convolution functions are functions that are inspired by looking at how visual cortex processes images. But there's nothing beyond that. There's nothing that says, oh, and by the way, if you engage in a word task, this is how it should affect the vision task that you're doing. There are ideas about how we could co-train systems to do these kinds of things, but we really don't understand the cognitive architecture that allows this kind of rich interaction and adaptive response to inputs coming in from various different sources over extended time periods that then enable fluid changes of plans without losing track of what you were trying to do 10 minutes ago or a day ago or even a year ago, right? You can come back to any of these tasks. And even GPT-3, which is, was until last week sort of the state of the art for a large language model, which was published, by the way, under the heading, the title was "Attention is All You Need." So it's explicitly a neural network that machine learning that tries to build in some notion of attention is actually hopeless. If you just push the button and let it run, it ends up rambling, losing track of what it said earlier, contradicting itself, having no way of recognizing that it's contradicted itself, right? So all of these products that you see, look at what GPT-3 did. Some human being has gone there and go, oh, that's really good. Let's publish that one, right? Or in the case of the famous Guardian newspaper article that says this article was written by a computer, they actually, started with half a dozen prompts and then massaged it into a single piece, rearranging the order in which GPT produced it. The editor's comment is, well, we do that for humans too. But the fact is that GPT can't do it for itself. It can't be the editor either, right? So even if an author needs an editor, nevertheless, the author could also be an editor, right? Can also sit down with their incoherent ramblings and turn it into something, or semi-coherent ramblings, I should say, and turn it into something worthwhile. So this kind of engaged, sustained, repeated interaction over time doesn't work.
There's one issue we haven't touched upon yet, which is that of explainability. And there's a lot of discussion going on in the AI research community on how to bring level of explainability to these systems. What are your views on this?
So thinking about explainability in AI, yes, this is a very topical issue, a hot topic, we'll say. A lot of people are writing about explainability. And I think the first question we have to ask is explainable to whom? So if we go back to the self-driving car kind of example, the way in which the system's decisions have to be explainable to the end user, the owner of the car or the person who's riding in the car, is going to be different from the way it has to be explainable, let's say, to the accident investigator or to the marketer or to the coder or to the product developer. And what counts as a good explanation in each of those cases is going to be different. And I think what makes teaching hard is the same thing that makes explanation hard in this case. That is, teaching is about explaining difficult concepts to students. And what makes it hard is one often doesn't have a good appreciation of what it is that the student already knows in order to be able to calibrate that explanation to their state of knowledge. And a lot of teaching, from my perspective, why I like the so-called Socratic method, is that you have a conversation with the students. You figure out what they know and what they don't know. You challenge them to tell you what they think they know. And then you move them along by sort of pointing out where that self-knowledge, or that's what they think is their own understanding, is flawed in various ways. And I think that we won't have fully explainable AI in the sense that we want explainable AI, in the sense that I can try to give you an explanation of my own actions, until we have AI that can also build a model of the person who's asking for the explanation. And that's already to solve the problem, right? You've just pushed the very problem of building artificial general intelligence back another level here to say, you're not going to be able to give good explanations. Now, you might be able to give good enough explanations if you have certain narrow, circumscribed objectives in mind. So if you are concerned about, let's say, fairness in issuing loans, and some bank is using some software, you might be able to say, well, here are the things that we want the machine or the algorithm be able to tell us about its own performance. But that's not going to generalize very well to other kinds of situations or circumstances. But nevertheless, a sort of cliche mantra here is, don't let the perfect be the enemy of the good. Some moves in that direction are worthwhile, and lots of people are trying out various methods for giving those kinds of limited explanations. But in general, explainable AI, may be out of reach for the time being.
But you're saying there's a high risk of perpetuating our own biases rather than finding ways of overcoming them.
I think that that's true. And I think that it also goes to some of my concerns about the way in which projects like GPT-3 are presented, where some chunk of text is put out there and you or I can look at it and go, oh, that's pretty good, right? But we're then making that judgment from some unspoken assumptions about what counts as good or what counts as worthwhile here. So if I've got an explanation, I've got some machine telling me, well, to make this decision about loan, I did not look at these factors. I did look at these factors. They were weighted in this way. And if you had tweaked the, this factor, this amount, it would or would not have changed the decision in this way. You might look at that and go, that's pretty good, without realizing that nevertheless, that system is going to perpetuate, as you put it, certain biases that you already have or that already exist in the social system. So we don't have a good handle, I think, on that. But again, coming from a philosophy of science, I think that and other people are thinking this too, there ought to be a more experimental approach. So this is actually a really interesting question in the philosophy of science explanation is, do we ever have explanations of single events, which are idiosyncratic? Or do we get explanations for class of events where we kind of average out over details? So I might not be able to give an explanation for why you didn't get this loan, but looking at 500 decisions, I might be able to say, on the whole, those who got it had these characteristics and those who didn't have those characteristics. That's still like anything else. You can not smoke and still get lung cancer, or you can smoke and not get lung cancer. The best we can do is give a sort of a group level account of what the causal factors are, without being able to attribute any particular case to to a specific cause. I think very much the same is going on here with AI explainability.
Following on from that, Colin, how do you see this apply to the many different approaches to machine learning and AI?
Yeah, I mean, there's a lot packed into that question, and I would actually want to make even a 3 or 4 part distinction, because there's classical symbolic, which actually had very little learning capability whatsoever, and then there's sort of older learning methods, or learning methods that are not based on deep neural network group, basically gradient descent types of algorithms, to put a technical term on it. And then you've got these more current hot deep learning models, which can operate in a variety of ways. So there's supervised learning, there's reinforcement learning, there's unsupervised learning, which also cross-cuts some of those other categories. And the reason I make that distinction, not just to be pedantic, is that when we look at the most successful systems, there is often a hybrid nature to them. So hybrid, not in the sense that Wendell and I were talking about with respect to top-down versus bottom-up approaches to morality, but hybrid between symbolic and non-symbolic aspects of this. So take the renowned AlphaGo that plays the game of Go at a very high level to beat the master Go player, Lee Sedol. That starts off with a fully symbolic engine for the rules of the game. That is, what moves are allowable is not something that the network learned. All the network learned in the Lee Sedol version of AlphaGo was which moves were more likely to produce a good outcome in terms of winning the game. So it didn't learn the rules at all. Go one step further to AlphaGo 0, where they do have it acquire the rules of the game as well as the strategies for the game from experience. Still, some programmer decided that in order to train a network, the network should have inputs that tell it there's a piece on this position, a white piece here, a black piece there. And so the categories that the machine has to learn about are given from outside the system. They're kind of external symbol. Whereas a kid learning to play games actually has to learn, oh, that's a piece, right? So we're still a long way from a system that completely, from a neural network alone, gets everything it needs to know in order to play an effective game. And here we're just talking about a game. Now, generalize that to getting through the full range of physical and social situations that real organisms have to navigate, humans and animals, by the way. Humans facilitated by having a rich symbolic system external to them, language specifically, but nevertheless, a much more powerful kind of architecture and set of learning methods seems necessary to be there. So I think that the answer to what how you're going to evaluate whether you understand this system requires attention really to the, as you were suggesting, to the details of the particular systems, how they're implemented, what the strengths and weaknesses are of each of those. You can't take AlphaGo, even AlphaGo 0, off the shelf and expect it to learn to play chess. You can take another system that's built on the same design principles, but still customized for chess, right, to do that. A child can learn chess and Go and play the two simultaneously. AlphaGo chess plays chess. AlphaGo 0 plays Alpha 0 chess, but I've been calling it it wasn't AlphaGo 0, AlphaGo chess. It was Alpha 0 chess, plays chess, learns the rules from scratch, but it only plays chess. So this kind of fluid intelligence lets you jump around, recognize at a very high level something you learned in one context might even apply. If I know Wendell's a a careless, inattentive chess player, I might expect them to be a careless, inattentive Go player as well. So I can transfer that knowledge to this other domain and make some inferences about how it applies. So all of these things are necessary then, I think, for giving the kinds of explanations and monitoring them for the kinds of ethical outcomes that we're concerned with. If I know Wendell's inattentive about certain things, then I might need to stay on top of him when it comes to whether or not he's going to make the ethically correct decision in some other completely different context as well. So we can overgeneralize the experience that we have as well as undergeneralizing it. And I'll bring this right back to the very concept of wisdom here, which is sort of understanding the limits of one's own knowledge. So that I've learned something about Wendell in one context may or may not allow me to predict something about his behavior in another context. And it takes a fair amount of understanding of the limitations of my own experience with Wendell and with other people to be able to determine whether or not it's legitimate for me to do that kind of generalization.
So what you're saying, Colin, is that we need wisdom through the lifespan of the technology, but we also need wisdom in terms of how we relate to and how we choose the different approaches to guide the development of these quite transformative and powerful technologies and
Yes.
scientific methods.
Yeah, I think that's exactly right. And a number of people have been focused on such issues as technological unemployment. I know Wendell has thought about this quite a bit too. Sort of, is it wise to roll out all these machines given the repercussions that might have for employment? But I think that there are other kinds of issues here too, where it's not just technological unemployment. It's something that the two of us wrote about in the book a little bit too, is sort of deferral to the machine. It's hinted in the title of the paper I mentioned, abdication of responsibility. So is it wise to put a very complicated advisory system in front of people when they don't have any way of understanding? You're not providing with the means of understanding the nature of the decision. They don't know whether they should go along with it or not. And furthermore, they may be lulled into a false sense of security because their experience to this point has been generally positive. And so they sort of just assume it's going to continue to be positive. It's a very natural human response to have to something that seems to be working well. So how do we keep throwing something into the mix that makes people sit up and take notice and realize that they really didn't have a good understanding? That might be more important than having the system explain itself when it goes wrong, or explain every darn decision. You don't want an explanation for me for every decision that I make. It would get tedious, right? But we don't just want explanations for when things go wrong. That's too late. What we want is some way of capturing the limitations of our knowledge by giving people circumstances regularly where they realize they don't fully understand what the system is doing. And that, as I was saying, might be more important than having the system explain itself. Just throw a curveball from time to time and see and wake people up with it.
Do you feel that there is sufficient openness around discussing the limitations of these systems?
So that's a very tricky question because, of course, many of the systems are behind some sort of protective intellectual property agreement or restricted in other ways. GPT-3 being another interesting case in point because GPT-2, which was its predecessor, a much smaller language model, was the full source code. It's OpenAI. They're supposed to be open source of everything. It was released to researchers to interact with, play with, inspect as they wished. When we get to OpenAI's GPT-3, OpenAI declares that this thing is so powerful that it's dangerous to let it out in the wild. to let researchers see what's really going on underneath the hood. Then they make an agreement with Microsoft, and Microsoft regulates who gets to interact with it through the so-called API, an application programming interface, where you can send it queries and get responses back, but you still can't do the full range of systematic experimentation with it that one would like to do as a researcher. And yet it's being licensed to corporations to run systems such as their online chatbots for product assistance and so on. Most people going onto those are not going to interact with them in ways that are designed to break the system as well. When you put a chatbot on Twitter, not everybody, but a significant proportion of people deliberately go out and try to make it fail. And that's what happened with the Delphi project. And they should have predicted that would happen. They seemed blindsided by it. If I'm interacting with a chatbot on a corporate website, a retailer or something, I'm generally not in that kind of skeptical mood, but nobody is either. So this maybe people ought to be invited to try to break these systems. But then, how quickly could you get can I help you chatbot using offensive terms or saying offensive things? It's actually, I would suspect you can do it pretty darn quickly. They're going to have some keyword filters, but you can probably, tell them that your name is something offensive, and it will repeat it back to you, and then construct queries in such a way that will seem to be making offensive statements about certain groups of people. So, and they can't anticipate all of these, and they don't get. I don't think there's been as much testing as there should be of this kind of thing.
And why do you think that is?
Yeah, I think it's, again, coming back to the cost-benefit analysis that corporate entities are doing with respect to their profit line. So it costs money to do this. Now, in the national security or even private security area, the entities that are producing these systems, first, there's a very high cost if they get it wrong. And so there's a lot more urgency to get it right, and especially if it's being done for public, government entities. There's also political costs for getting it wrong from those who are ordering such systems. So there tends to be more resources put that way. If you offend some customer because the chatbot can be tweaked to say something bad, that's not the same as allowing somebody into a highly secure area doing things that they shouldn't be doing there. So I think a lot of companies probably just figure this is a cost of doing business that they can handle.
Thank you so much, Colin, for sharing your time, deep insights, and expertise with us. What a rich and thought-provoking discussion this has been. Thank you to our listeners for tuning in, and a special thanks to the team at the Carnegie Council for hosting and producing this podcast. For the latest content of ethics and international affairs, be sure to follow us on social media at Carnegie Council. My name is Anja Kaspersen.
And my name is Wendell Wallach. Thank you ever so much.
And I hope we earned the privilege of your time. Thank you.